What if you were marooned all alone on a desert island with no technology, no log tables, no slide rule, nothing? But you had to evaluate a close approximation of this number before a ship would come for you. At least one great thing about the island is that there's an abandoned paper factory and an abandoned pencil factory, and they both have tons of leftover paper and pencils just sitting around perfectly preserved. Would you get off the island? Well, we're going to look at how we might do that in this video. There is a requirement to this system. You must first know how to figure out logs by hand. For instance, log 35, natural log 35. And I have included a link in the description to my video on how to do that. So I suggest stopping here and watching that one first. And in that video further includes a link to the derivation of Simpson's rule, which I'm using as the basis for this whole thing. So the ideal order is this. First of all, it would be very helpful to know the derivation of Simpson's rule so you understand exactly what's going on and how it works. Then use that to master finding logs by hand. And then go ahead and watch this video on extending the technique to find decimal powers by hand. One last thing, I'm only using natural logs for all of this. You could do the same thing if you wanted to use common logs. I prefer natural log because it just lends itself to so many other things in math, and it's just a preference. And another thing, I'm not going to keep saying natural log. I'm just going to say log because that tends to be kind of a habit anyway in higher math circles. So you want to say log of 35. Or, you want to say natural log of 35, you just say log of 35. Okay, so we're wanting to figure out what this number is. This is the answer, but this is what we wouldn't know, and we would have to come up with something close to this to get off that island. And I'm guessing you're watching this video because you don't like any more than I do being dependent on pushing buttons, using technology to get an answer that you have no idea where it came from or how you could even do something like this. And I love knowing that if I were on a desert island, I could do pretty much any math I needed to totally by hand. It would take astronomical amounts of time possibly, but I could still get it done. Besides, you're on an island, what do you got to do other than do math, other than, go get a coconut once in a while, or you might have to fight off a monitor lizard or something. But anyway, so first of all, I have a list of logs here. And like I said, I'm doing natural log, not common log, but you could do all the same stuff with common log if you wanted that to be your default, but you can easily convert from natural log to common log with the change of base formula anyway, so it doesn't really matter. All of these logs here I have calculated by hand using the technique in the video that I referred to, that I have the link to in the description. And so if you were on that island, you'd first have to figure out all of this stuff. It would take a few hours, but you could do it. So natural log of 1.1 up to log of 2.8 would be enough to do decimal powers. You don't need to go past log of 2.8 to do decimal powers, and I'll show you why. And then just to do logs in general, because we are going to have to figure out a log in this procedure. Well, one of the key things you can do there is first figure out the natural logs of the first few primes, 3, 5, 7, 11, maybe 13, but you can go a really long way toward figuring out logs of numbers just with these numbers here and the technique of figuring out a residual log that would result from taking a number, factoring it into these primes, and then that leftover piece, you're going to have to actually do the hardcore procedure to figure out the log of the leftover one. That you may not know what I'm talking about, but it's in that video that I referred to. So I'm going to assume that you already know how to do all of this stuff by hand, and that is our starting place. So we're going to go ahead and start in on this number. By the way, I do want to mention, when I said I did these by hand, I did use multiplication and division on my calculator. I didn't use the log buttons because I'm not going to do all this, take hours when I don't have to. I have done these before completely by hand, including the tedious multiplication and division, which can be pretty intense, and it'll take you between 1 and 2 hours typically to do it. So I have done what I'm teaching you to do, but don't think I did all of this stuff here, not even doing the multiplication and division with the calculator. But of course, we all know we can do that if we have to. Okay, so I have this number here, and we don't know what this is. So let's just take it and start working with it. So we're going to do some manipulation. First thing I'm going to do is, now I'm assuming you know log properties. If you don't, you need to. And I also recommend learning to prove the log properties, because you're watching this video because you want to understand, and that would be part of it. So that way you can pretty much see through this whole thing. It becomes transparent, everything that's going on. I like the feeling of knowing that stuff. And then exponent properties. So remember, if you have same bases getting multiplied, well, then you may remember that you would add the exponents, but then you could also split them up the same way. You could take x to the 5 and go back to x to the 2 times x to the 3. So I'm probably not going to dwell a lot on those. I'm assuming you know those already. So exponent properties and log properties are crucial to understanding what's going on here. Well, so I'm going to take the 25.3 and break it up into 25.3 to the 2 times 25.3 to the decimal part. And in this part, that's just arithmetic. That's just basic multiplication. It could be tedious, especially if that's a big power. But it's the decimal powers, that are the most confusing to people generally. Okay, so let's keep going. So I'm going to go ahead and do the squaring of the 25.3. So I got, and like I said, I didn't do this by hand, but I could if I needed to. So that's this. And then we still have the 25.3 to the 78. Okay, now we're going to use some more log properties, natural log properties. And okay, before I keep writing here, let me get a different color and just show you what I'm going to do. So I'm going to take the 25.3 to the 78.78, and I'm going to write that as e to the natural log of 25.3 to the 0.78. So if you know log properties, this is the same thing as this, but we're going to convert this into an expression with the number e as the base. Now continuing to use log properties, made a little mistake there, I had to correct it. So using log properties, we know that this exponent can come in front of it can come right here in front of the log. So still not doing anything with this, but we have e to the 0.78 times log 25.3. Okay, now this is where we need to turn this into a straight decimal. And so to do that, you'd have to figure out log of 25.3. So now I'm not going to do that in this video because I show how to do that in the other video. So we're going to assume that we've already done that. And so now we turn this into a decimal and also multiplied it by this. And when I did all that, I got e to the 2.52. Okay, well now we're going to do something similar as we did with the 25.3. We're going to bust up using exponent properties. We're going to, well, let me just write it. We're going to have e to the 2 times e to the 0.52. Okay, now this, again, you're going to have to bite the bullet. Hopefully it's not a big exponent, but e is approximately 2.7183. So knowing that, you could do whatever this is. So what I'm going to write next here is where I actually squared e and multiplied it with this already. And what did that give me? So that leaves me with 44,729.6609. And now we have a leftover e to the 0.52. Last thing I'm going to do is I am simply going to, I'm going to write this as x, because now we've got it whittled down to this. If I can figure out x, which is e to the 0.52, well, then I can go ahead and multiply it by this, and we have our answer. So we basically now have a final problem, e to the 52 equals x, and this is what we have to solve. We have to be able to figure out this number. So we're getting it whittled down here. Now you might think, well, this is really not much better than this. I mean, we're trying to take a decimal power. We still have that here. What have we really gained? Well, just hang on, because we're almost there. We're in the final stages now. Well, I don't know. It depends on how accurate you would want to try to be, because there's all kinds of finagling you could do. But what I'm going to do right now is I'm going to rewrite this as, and again, I'm assuming you know the log properties. This is the same thing as saying natural log of x equals 0.52. And this, if we know this, we have our answer. We just put it here, multiply, and we have our original number we were after. So this here, in the old days, you would look on a log table before calculators, and you'd either have this number and you could get this one, so you'd take in a log, or you would have this number and get this number, which is an anti-log. The same table gives you obviously both. You can go either direction. So we need the anti-log of 0.52. Well, here's why I said you need to have a table like this made up, because now you can look at this and look at these values and see where it fits in between. So 0.52, so that would be in between here, between 1.6 and 1.7. So we already know that this x value is between 1.6 and 1.7. So we're almost there. However, depending on how accurate you want to be, you really should think, okay, 0.52, how far is it from this and how far is it from this? It's obviously real close to being 0.53. It's much closer to 5.3 than it is to 0.53 than 0.47. And so you might at this point just say, well, I'm going to go with, I'm looking at the wrong, I keep looking at the wrong one. So I'm going to go with maybe 1.68, something like that. And if you did that, okay, you would be really close. And now you could go ahead and multiply this by 1.68, and that would give the answer of 7945.83. And that is the number we're after. So 7945, and the real answer is 7955. Well, for being in the thousands, that's a pretty darn good approximation of this number. So let's just, before I finish the video, let's look at how we could finagle this a little further, maybe get slightly more accurate. Okay, is there a way we could get this a little more accurate? You might use an approximation technique that you might have seen done with square roots, and that's where you look at the two known values. Let me get a different color. And so we know that log of 1.6 is 0.4700, 1.7 it's 5.5307. It's this one. And we know that in between we're looking for what number would give us the 0.52. Well, so you could just use proportions, take this distance divided by this distance, and that would give you the percentage of how far from here to here we are. And so when I did that, I did, so that gave me 0.05. So a distance of 0.05 over a distance of 0.0606. And that gave me 0.825. So we're about 80%, 82.5% between here and here. And now this is only an approximation because this is not linear, but neither are square roots. But we use this technique to kind of get us closer. And so if we start at the 1.6, and then we add 80% of this distance going on from here. So we're doing 0.825 times, and we're doing tenths here. So it's a little over 80% of the next tenth. That gives us 1.68. So that kind of backs up that this wasn't a bad guess. So this is where we are. But now what you could do, if you want to get more accurate and you got tons of time on that desert island, well, then take log of 1.68 with the techniques in that other video. And if you do that, you get 0.5187. But we know we want to be up to 0.52. So we know this needs to be a little bigger. So we know we don't want to get to 1.7, so maybe try 1.69. So it's kind of a guess and check situation now. So if I take this log, I get 0.5247. Well, it's a little bigger than this. So what if I do maybe 0.168, 1.685? So when I did that, so log of 1.685 is this. So we're still above this. Maybe try, now this is, of course, on that desert island, it's taken a lot of time to do these individual logs, but you got time, and the main thing is you want to know that you could do this if you had to. If we did like 1.682, so what do I get when I do that? So log, I'm using my calculator here, but on the island, of course, we would be doing it by hand. That gives me 51,998. That is really close to this. So I'm going to go with 1.682. So let's try that. So if our that would give us 4,729.6609. So that was x, and we figured out that our x, the best we can figure, is 1.682. When we do that multiplication, we get 7955. This was the technology answer, and this is our answer by hand on the desert island. So that's actually a really good approximation. And we see that you could put in whatever time it takes you to do these techniques, finagle, guess check, whatever you have to do, and you could actually you could evaluate a decimal power. So the good news is we're getting off the island because we proved that we're not dependent on technology. We can do the math by hand. The calculator is just a way to speed us up. I wanted to close with a couple of techniques for just more finagling. So if we take the two values that we were in between, so there's different things we could do. We could add both sides and get other logs. So log of 1.6 plus log of 1.7, by log properties, that's log of this times this, and that would be 2.72. And over here it's just straight addition. So you can get a log from two other logs. You could also do subtraction and get another log. But now if we're looking for an in-between value, because maybe we want to kind of squeeze between two values and then narrow it down to squeeze between two more values and stuff like that, well, then you could take an average. So basically, if we want to average both sides, we've already added them up. So then to average, we would just divide by 2. So I'm going to multiply both sides by 1/2. And so here on the left, we would get 0.50035. And then by log properties, this, when we cut this in half, we're multiplying it by 1/2. Well, that 1/2 would become an exponent up here. And so then we would take the square root of 2.72, and that would give us another log. So the square root of 2.72 is 1.6492, and we can totally do square roots by hand. And here we have another log, and we're between these two values. So now we're at about 0.5. So we're here instead of here, and then now you've got two values that are closer together to narrow down from. So I just wanted to point out that technique before closing the video.